This video is an introduction to an ellipse. An ellipse is defined as the set of all points in a plane such that the sum of the distances from the 2 points in the plane is constant. And these 2 fixed points are called foci. So the foci here are at negative c0 and c0. If you just have one of them, we call that a focus. Okay. Now that definition talks about having a fixed length. In other words, imagine that you had a string with its endpoints tied at negative c0 and c0, and you pulled that string tight, you had a little bit of slack, so you can kind of drag it around. And as that point, as I were to drag the string around here, no matter where I put the string, let's say even over right here, the total length from c0 to the edge back to the other focus, is still going to be the same length no matter where I put it. Okay, and that's what's going to give the ellipse its shape. These 2 foci and that fixed string length will make that oblong shape. Now some more definitions. So the major axis has a length of 2a units and the minor axis has a length of 2b units. So major is the much longer axis from negative a to a, so this is the major. And the minor axis from negative b to b. So major is longer, minor is smaller. And both of these axes are lines of symmetry and they intersect at the center here. Okay, now the foci always lie on the major axis. Since the foci are going left and right, as I move them further away, it makes the major axis longer, makes it more oblong. If the foci were closer, and on top of each other, you would actually have a circle. If the foci go up and down, that's going to make the ellipse elongated vertically. Now, the sum of the distances from the foci to any point on the ellipse is the same as the major axis. What that means basically is if I were to take the string, say let's once again focus on the piece up here, and I were to drag it all the way over here to the left, it would lie flat from here to here, plus the piece that was attached to negative c0 would also be over here, so a little bit of overlap. And so the string from c0 would lie flat here, negative c0 would lie flat right here, so that little bit of overlap is the same as this section over here. So just let that sink in. Now the distance from the center of a foci, let's see, is c units. By the Pythagorean theorem, a, b, and c are related to the equation c squared equals a squared minus b squared. So it looks like the Pythagorean theorem except for the minus. You can look online and see how that was derived and how the relationship of a, c, and b relate to each other. Okay, a summary chart of ellipses. Now the standard form equation of an ellipse can be written as 2 different ways. Now both of these are the same form except for the a and the b switch, and I'll explain that later. Now analyzing it, just looking at these equations, they look very much like the equation for a circle, except that you have a denominator and the equation is equal to 1. So let's talk about the first one. You have x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. So the center is hk, just like a circle. Now the direction of the major axis. So where it goes longer left and right, okay, horizontally, the a is bigger underneath, so it's going to stretch longer left and right. On the other hand, if the a is underneath the y values, or the y part of the equation, it's going to stretch the ellipse vertically. Okay. Now, this isn't stuff you have to memorize, but it's just good information to know. It's going to be more natural once you start graphing it, and that this will all make sense. So the foci have to go left and right to make it stretch that way. So I take the center and I add c units left, or subtract c units and c units to the right to get the foci. And here I take the center hk and I go up c and down c to get the foci. The major axis is 2a, whichever way you go. The length of the minor axis is 2b, whichever way you go.